Hi, today we'll be looking more at Rust basics. We'll be looking at iteration, ownership, and functions. Just a little bit about each of those. So let's get started. I'm going to give you a quick introduction to functions. So we created a new cargo package, and we have our main with a print line in here. So just get rid of that print line. Now we want to create another function below this main function, and it looks very similar. So we fn for function and then our function. Now these brackets here will where you'll pass your arguments. So we'll want to pass, for example, x, which will be an integer. And then we can put our return type by doing an arrow and then giving our return type. So we'll return a bool, true or false. And then these curly brackets for our function body. Now this function will only be accessible in this main.rs file. You'd want to make it so it's by default it's private. So to make it public, you just type pub at the start, and now it's public and you can access it from other places. So we'll create a function that will test our input to see if it's a certain number. So we're going to use what's called a match statement in Rust, and these are basically like switch statements in Java, but they are much more useful. They can do a lot more than just a simple switch statement. They're usually used for error handling, but I'm just going to introduce it here for the sake of introducing a new concept. So we're going to match on x, our i32 that we've passed in. And if it's 5, then we return true. So we want to see if it's a 5. Will return true. And then if it's not a 5, so anything else, this underscore basically represents anything else in a match statement. So if it's anything else, we'll return false. So we're basically checking to see if x is 5, otherwise returning false. And we don't need a return statement in this case for this function. Rust will infer that for us. So now we can do y equals our function, and then we could pass in a value, let's say 4, and now we can print our y value. So we're going to use the debug print statement. That we showed this in a video before, how to print things, and we're going to print y. Now y will be a boolean, and to run this we will do cargo run in our terminal down here below. So I just forgot to put this as let y equal our function. Small mistake. There we go. As you can see here, it returns false. So that worked perfectly. Now that's how to create a basic function. So what I want to do next are for loops and iteration in Rust. It's a very basic thing in most languages, but first I have to introduce borrowing and ownership in Rust, which makes it a little bit trickier. And this is where people start to get a little bit lost using Rust, and once you break it down, it's not so difficult, and the compiler will help you 9 times out of 10 anyways to correct whatever mistakes you make. So let's do something simple here first. Let's let x equal string from hello. So this will create a string like you have in Java where you can manipulate it. So this will create a struct of string, and it will take a static string hello. So in Rust there's 2 types of strings. So there's the string type, which is the common string that you'd find in most languages, and it has ownership over the contents of a string. There's also a primitive type string of str, and that's like a static string slice. So basically what this breaks down to is a string that we see here is a growable string. And you can do things like get the length and add and remove from it quite easily like you do in other languages. So now we do let y equal x. Now you would imagine here that if we do print line and we do print line of, now we print y. Oops. Now you would imagine this will print y for us. Let me just comment out our function from above. We don't need this anymore either. And there you go. So it prints hello. Now what would happen if we try to print x? So that should work, right? Because x is here, we declared it. But we run into an issue. So the value borrowed here after move. Move occurs because x has type string, which does not implement the copy trait. Value moved here. So it's telling us our value has been moved to y. So x no longer has the value, y has the value. And string doesn't implement copy. So copy, what copy would do is just create a whole brand new deep copy of x. But we're not doing that here. Instead, we're just moving the whole value to y. This is where the idea of ownership comes in. So in Rust, you have one owner of a value. You can copy a primitive type like an integer or a static string or a float or Boolean and so on. So here we have x equals 5. So if we do y equals x, it will make a copy of it. So now we'll have a copy of x. And here I drew a little diagram to show it pointing to memory. So now we have x equals 5, which points to here in memory, and our copy y equals 5 points to here in memory. However, you can't do this for string types. So instead, what you'd have to do is reference the value that the string is pointing to. So to fix this issue, what we can do is do x.clone. And clone will just make a whole new copy of it. And now it should work perfectly because they're two separate values now. And there you go, we have hello twice, so it worked. So the reason Rust does this is because Rust doesn't have a garbage collector. So if we had a value x, which is a pointer to somewhere in a place in memory, if x is, for example, in a function and that function is over, we don't use it anymore, it will go out of scope and Rust will drop it for us and remove it from memory. In other languages, this is done through a garbage collector, which figures this all out for us. But in Rust, we have to be mindful of this ourselves. Value only lives as long as its lifetime. Now, lifetimes are a whole other topic. I'll go into another video, but I recommend you read about them. They'll basically tell you how long a value will be in our program before it's dropped. So now that we're aware of this concept of ownership and values moving between owners, let's start to look at for loops and iteration. Right, so let's create a simple vector first. So let our vec equal vec. We'll put some names in here. John. We'll put Tom, Mary. Give them capital letters. In Rust, you put a comma at the last addition when you're doing arrays and so on. It's just to avoid error, because a lot of languages you would leave this out, but that causes more problems than it's worth. It's best just to put them in, and Rust lets you do that. So if we ever add another value here, like Sam, we're not worried about having a missing comma here, because we always put it in. And that's the useful thing about this. Let's do a simple for loop for val in our vec. This is how you do a for loop in Rust. Now, I know in other languages you do something like this. You'd have I equals 0, I less than our vec dot length I plus plus, and then you'd have your body. But in Rust, we save a lot of effort by having it like this. We just put for value in our vec. And you can also get the index as well if you wanted, but for now we're just getting the value. And let's just print it each time. Now let's just show that working. Let me just comment out all this stuff beforehand. We don't need that anymore. There we go. So John, Tom, Mary, Sam. So it prints each value as it goes through the loop. Now that looks simple enough, but what's happening here is a little bit trickier than you'd imagine. So what would happen if I tried to print our vector after the fact? And if we just get whatever's at index, I don't know, 2. So index 2 should be Mary. If we try to run that, oh, we can't because the value has been borrowed after move. So what's happening here is this for loop, the values are being moved into the loop. And then we're not able to use them then after because they've already been moved into the loop. So a good way to avoid this problem is by using an iterator. An iterator will, rather than taking the values directly, will take them as a reference. So if you'd imagine you had X and it's a pointer to a place in memory, a reference will just be able to read this pointer, this place in memory. It won't actually be able to do anything else. Unless you made it mutable, but you can only make one mutable reference. But that's a story for another time. So we're basically making a reference to this pointer to read it, but we're not actually going to move the value. So now this iterator will do that for us. It will reference the value rather than moving them for us. So now if we run it, you can see that we get our iteration and then our final printout sum Mary. Now ownership, borrowing, and references and so on are a very big topic in Rust and very important to understand, and I've only touched the very, very surface of these concepts. To get a more detailed view on these, I recommend looking at ownership in the Rust book, reading the ownership, borrowing, and lifetimes parts of this book. Now there is a way to get multiple owners for a value, despite what I said earlier, and this is through reference counting. This RC in Rust will let you have multiple ownerships, will let you have multiple owners, but it's a little bit complicated and it's for another video. I recommend checking out the ownership section in the Rust book, which can be found online. Just type in Rust Programming Language Book, and there's the ownership section, a borrowing section, and a lifetime section. I recommend checking those out, reading them, and there's a lot more to this than what I've covered so far. But as a brief introduction, I hope you found it helpful, so subscribe, like, and all that. Thanks.